Good morning once again and welcome to my YouTube channel, Maths with Ease by Mr. Kamotho. And in this video, I want us to go straight to explain the nature of turning points. We have been learning about turning points and we know in fact, the only fact about the gradient of turning point is always when dy dx is equals to 0. dy dx is equals to 0. And with that fact, find the turning point of the curve y is equals to 2x cubed minus 3x squared minus 12 plus 1. So when we have a curve that looks like y is equals to 2x cubed minus 3x squared minus 12x and plus 1. First of all, we must understand that this one is a cubic function because the highest power is 3. And a cubic function, there's a way we can know the shape of the cubic function, and that's one of the way that we are going to use to actually solve this question. First of all, the value of a, which is 2, is a is greater than 0. And when a is greater than 0, then the shape of any cubic function is that way. And we know when a is less than 0, the shape is this way. So here, this is a maximum point, and this is a minimum point. This is a minimum point, and this is a maximum point. Having had that, now we need, first of all, to just know at what point do we have the turning point. And we are going to use this fact. The gradient of a curve at the turning point is equals to 0. So if this is the y, then from the function itself, we should be able to calculate the gradient by differentiating the function y with respect to x, which is obviously equals to, now 6x squared, we are differentiating this function, minus 6x minus 12. This is what must be equals to 0 if we are talking about turning point. And because it is now a quadratic function, we have 6 here and 6 and 6. So before we can do anything, we can divide every term by 6, every term by 6, so that we have x squared minus x minus 2 is equals to 0. And this one you can just give it BAC approach. In this case, which two numbers do we add? They give us a minus 1, and we multiply, they give us a minus 2. And obviously this is minus 2 plus 1, and minus 2 times 1. They will give us negative 2. Now we can easily substitute the middle term and have x squared plus x minus 2, x minus 2 is 0. Factoring x outside, we have x into bracket x plus 1 minus 2 into bracket x plus 1, which is equals to 0. Now at this point, we have two brackets, and we have them as x minus 2, x plus 1 equals to 0. Multiplying these two brackets, the product is 0. It means that either of the bracket is 0, and if it happens that it is x minus 2, which is 0, then x is equals to 2, or x plus 1 is the one which is equals to 0, then x is equals to negative 1. Now, at that point, we can see that we have x being equals to negative 1 and x equals to positive 2. The negative is to the left. So we have a clue that the point that is having negative 1 is a maximum, and it could be this, because 2 has to be right of negative 1. So this could just be the minimum point. But before we can go further than that and start reasoning further. What point are we talking about? Because the question is, find the turning point of the curve, this one. Finding the turning point means giving the coordinates of the turning point. So for me, when x is equals to -1, we substitute it in the original equation to find y is equals to 2, -1 cubed minus 3, -1 squared minus 12, -1 plus 1. And we can all see that this is -2, and this is -3, and this is plus 12 plus 1. In other words, 13 minus 5 is 8. So we have one turning point. I don't want to declare it is the maximum, but for me it is the maximum. But we have one turning point so far whose coordinate is -1, 8. What about the turning point number 2? So when x is equals to 2, y is going to be 2 cubed minus 3, 2 squared minus 12, 2 plus 1. So we have this is 8 times 2, which is 16. This is 8 times 2, which is 16. This is 4 times 3 minus 12 minus 24 plus 1. And we have 17 minus 36. Let us confirm that. We have a total of positive 17 minus 36, if you could look at that. And we have this is -19. So we have turning point 2 whose coordinates are 2, -19. To me, this is the minimum, but I just don't want to declare that until now I teach the ways of identifying which one is the maximum and which one is the minimum. That is so easy. How to teach whether a point is maximum? We draw it like a table. We have a table there, and then we have dy dx, and then we have the shape. We have the shape. I will explain this. When x is -1, it should be there at the middle. The dy dx is 0 because we have seen it here. For dy dx to be 0, x has to be -1. And the shape of the curve is horizontal. But we would want to know what was the shape to the left of -1. Let's say -2. What is the dy dx? The dy dx, as we all know, is simple 6x squared minus 6x minus 12. And I would want to just bring it here for purpose of catching up with what we found. Dy dx is 6x squared minus 6x minus 12. So when x is -2, we have dy dx 6 minus 2 squared minus 6 -2 minus 12. So this is 4 times 6, which is 24. This is plus 12. This is minus 12. And the gradient here is positive 24. And a positive gradient, this is positive 24. And a positive gradient has this shape from bottom left to top right. What about when x is now to the right of this turning point? Let's say 0. When x is 0. When x is 0, the gradient again becomes 0 minus 0 minus 12. This is minus 12. And the gradient is negative, as you can see, and the shape of the negative gradient is simply that. That tells you that we have a maximum point at x is equals to -1 because the shape is very clear. But I would want now to go ahead and probably, if I may enlarge now this table, and I say, let me talk about the other point. When x is 2, the gradient, when x is 2 rather, the gradient is 0 and the shape of the gradient is horizontal. Why are we saying that? Because when x is equals to dy dx here is 0, and that is exactly what we found. What is now to the left of 2? We can easily use 0 is to the left of 2. Of course, you can see. If you are not trusting 0, you can just take one step to the left of 2 as 1 and talk about substituting it in the gradient. And we are talking about of 6, 1 squared minus 6 multiplied by 1 minus 12. This is 6 minus 6 minus 12. And this is negative 12. And as you can see, this is negative 12. And what is the shape? From top left to bottom right, as you can see. Now, to the right of 2, how is the curve behaving? Let's take when x is equals to 3. When x is equals to 3, then we have 3 squared minus 6 times 3 minus 12. This is 3 squared 9 times 6, 54, minus 18 minus 12. This is 54 minus 30, which is 24. It is positive 24, and the shape, as you expect, is simply that. So to speak, we are talking of a curve. We are simply talking of a curve that has a maxima and a minima at different points. And if we were just to sketch the curve here, I would have it drawn according to, let's have it here, just sketch the curve. This is -1, -1, the turning point is -1, 8, this is 8, that is a turning point, and we can already see it's coming from this side, and the other one is 2 minus, this is 2 all the way to, we can talk about minus 19. This is another turning point, and we can say that is the minimum according to the shape displayed on this table. That is a turning point, maxima, and this is maxima, and this is minima. Now, there is a very simple method that you can use to identify whether a point in a curve is a maxima or even a minima. That method, you don't even need to construct or to sketch all these graphs. We call it the method of second derivative. And I said on the slide, if you are keen, I will explain how to identify whether a point is a maxima or a minima using the second derivative. First of all, what is the first derivative, or rather the differential? I want to keep it over here. Dy dx for this particular purpose is 6x squared minus 6x minus 12. That is what we got after we differentiated the original function. And you can all see the original function is this. Now, to know whether a point is a maxima or a minima, we need to go for the second derivative. And what is a second derivative? A second derivative is the differential of the first derivative. In other words, what we have gotten after differentiating the function is called a gradient. Now we need to differentiate this gradient again to give us the second derivative. And before we can go further, how do we write the second derivative? D squared y over dx squared. When it is less than 0, then this is a maximum point. And when the second derivative is greater than 0, then this point is going to be a minimum. And we are now ready to go. What is the second derivative for this particular function? D squared y dx squared is 2 times 6, which is 12x minus 6. 12x minus 6. Now, we have 2 points to consider. At x is equals to -1, because it is a turning point. At x is equals to -1, now d squared y, the second derivative rather, is going to be 12 times -1 minus 6, which is basically minus 18. So minus 18, we all know this is less than 0, and therefore the point -1,8 is a maxima according to this. The point -1,8 is a maxima. The other one, we now should ask ourselves, at x is equals to 2, again, we go for the second derivative. D squared y dx squared becomes now 12 times 2 minus 6, which is basically 24 minus 6, which is positive 18. It goes without saying, now that 18 is well greater than 0, then the point we have 2 negative 19 is well explained to be a minima. It is a minima. That is very, very easy, and it can be used in all questions of this nature. Well, it was a long question, but there you are. You have been helped. Let us meet in the next video. Thank you.